Hello, my name is Sam Milstead. I am an escalation engineer for the TAC XR team. And today I'm going to be walking through MPLS, MPLS traffic engineering, segment routing, and segment routing traffic engineering. I will only be going over the basics. There are many different ways to configure these protocols, especially traffic engineering, but this is the basics of how to verify a data path through a network. So first, we're going to take a look at our topology. So we have two CE routers, CSR3 and CSR4, in AS number 1 and AS number 2. And then we have our service provider in AS 65000 with all XR routers. XRv6 and XRv9 are our PE routers that are paired using BGP between each other. Each router has a loopback interface with IP address, which is its own numerical value. So XRv6 would have 6.6.6.6, and CSR4 would have 4.4.4. So the first thing we're going to look at is basic packet path using L3VPN. So on CSR3, we can see that we're getting a address of 4.4.4.4 from CSR number 4. So that's coming all the way from XRv9 to XRv6 to CSR3. So if we trace the path, we will get the results of what the labels look like and any other data, such as the autonomous system. So our first hit is 3.6.0.1, which is this interface IP address on XRv6. Our next hit is 6.9.0.2, which is the interface IP address on XRv9, gig 0002. And it gives us a label of 24015. And our last hit is 4.9.0.2, which is CSR4. And then we will take a look at XRv6. First, we're going to look at a show route. Our VRF is customer A. So we can see our RD set here, 100, 100. We can see the label that's set, 24015, which matches to this output. Now, if we want some more details, we can go into Ceph. Show Ceph VRF customer A, 4.4.4.4 detail. We see that the next hop is 6.9.0.2, which is what we saw in the traceroute output, and the outgoing interface is gig 0002. Now, we also see this other next hop listed here of 2400002. Now, we don't see that label imposed. Instead, we see an implicit null. Now, if we look at the MPLS forwarding table, show MPLS forwarding, and we look for 2400002, we see there is a pop, and the prefix is 9.9.9.9/32. The outgoing interface is gig 0002, and next hop is 6902. So this is our basic L3VPN. Essentially, our transport label is an implicit null label because we are the PHP router, or penultimate hop popping router. And because of that, the only label that gets imposed is this 24015 label. We can also see the labeled output in BGP. Show BGP VPN v4 unicast labels. And we see that for 4.4.4.4, we have a label of 24015 that's assigned. Okay, so I just cost out the link, not really cost out, but increased the metric between XRV6 and XRV9, it costs to 1,000. And then on CSR3, I did a trace route again to 4.4.4.4. And as we can see, we're now receiving 2 labels. So when I go to XRV6 and I check the Ceph forwarding for this particular prefix, we can see that 2 labels are imposed, 24006 and 24015. Now, if we check in the MPLS forwarding table, now we also see here that 24002 is here, which is for the next hop 9.9.9.9. So we need to check 24002, and we see that that's the local label, but the actual outgoing label is 24006. So that's the top label that goes out, and then the bottom label is 24015, which again we can check in BGP. So by changing the transport, the underlying service label or L3VPN label has not changed at all. Now, if we come to the next router in the topology, XRV7, we should see 24006 on top. And we see 24006 as the local or the incoming label, and 24006 as the outgoing, which is what we also see here as well. And again, it's for the same prefix, 9.9.9.9. And if we then go to XRV10, we see that we have a POP label. Now, the reason why we have a POP instead of another label or a push or any other action is because this is the penultimate hop popping router or the PHP router. So this is the last router before the final router where the service label gets used, the 24015. So that means we strip off this 24006 label and we only send with 24015. Now, if we go to XRV9, we see 24015 becomes unlabeled, which means it gets popped, but there's no underlying labels, so it will have to perform another action. And it shows that it belongs to 4.4.4.4/32, but it's in a VRF. So we can check, show BGP VPN v4 unicast labels, local label 24015, and we can find which route distinguisher and which customer this belongs to. Next, we're going to add MPLS traffic engineering. So to add MPLS traffic engineering, most of the configs already exist on these routers. I just need to add one little configuration to enable it. So to add traffic engineering, you need MPLS traffic engineering under your area. You need MPLS traffic engineering router ID under your IGP as well. and then you need your interfaces. All your interfaces that want to participate in traffic engineering need to be in MPLS traffic engineering, but they also need to be in RSVP. Here is where you might establish how much bandwidth is allocated for a particular link. Now we do have an explicit path set up. So we do, now that I'm back on XRV6, we do have an explicit path set up. So essentially what I'm doing is I'm going from XRV6 to 7. So we have 6, 7. Then I have 7, 8. Then 8, 11, 10, 11, 9, and between 10 and number 9. Now we can check to see if this is a valid path or not. Show MPLS traffic engineering tunnels. And there's quite a few options. Now we can give the tunnel number. We are using tunnel number 4. And we can see that the operational state is up and the path is valid, signaling connected, which is good. Gives us all the hops. Now if we do detail, gives us some additional information. Probably the most important information is the outgoing interface and the outgoing label. So we know this is our outgoing interface, gig 0000, and our outgoing label is 24012. So now I'm going to add the static route, which tells us that if we want to get to 9.9.9.9, we're going to use this tunnel TE4. We're then going to go back to CSR number 3, do another trace route, and see how it looks compared to the last trace route. Okay, so we had a little hiccup there. It took a little while for the programming to take place, but we added the router static with going to 9.9.9.9/32, taking tunnel TE4 on XRV6, issued the trace route, and now we can see that we're taking the full path going from 6 to 7, 7 to 8, 8 to 11, 11 to 10, 10 to 9, and then to the final destination. So if we check the Ceph forwarding table, so we see there is this address for 9.9.9.9, 24002, and then there is 24015. So let's look at MPLS forwarding. So 24002 has a POP, but it's pointed to TE tunnel number 4. So if we also check Ceph for 9.9.9.9/32, we see it's going to tunnel TE4. So we then need to look at tunnel TE4, which we did just a minute ago, show MPLS traffic engineering tunnels for detail. And we see our outgoing label is 24012, which we see here. And we can check this all along the path. So let's take router number 10, for instance. So as we can see on router number 10, 24012, which was the outgoing label for traffic engineering, becomes a POP label. On the other routers, such as XRV11, we would see the same outgoing label of 24012. It tells us this belongs to TE tunnel number 4, that's the prefix or ID, and it tells us outgoing interface and next hop. On XRV9, which is our PE, 24015 is unlabeled and belongs to 4.4.4.4/32. So next, what we're going to do is go from the reverse direction. So we're going to go from CSR4 to CSR3, and this time we're going to use segment routing. So segment routing, for the most part, is in place in these routers. I will show that now. So we have segment routing MPLS. What we need to add is segment routing SR prefer. SR prefer means that we will use segment routing over instead of LDP. So LDP is preferred over segment routing by default. And we already have our prefix SID enabled. So basically, this means in our block for prefix SIDs, we've allocated index number 9 to loopback 0, and it's being advertised in our IGP. So if we check show MPLS forwarding, we can see all the different prefixes, 6, 7, 8, 10, 11, etc. And then if we go to XRV number 6, we need to take the same action. Okay, now we will log into CSR number 4. So we can see that we have a route to 3.3.3.3, which is CSR number 3. We will now try a trace route now that we're using segment routing. Now remember, we're still doing L3VPN, so we still have a service label. The main difference is we're now using segment routing instead of LDP for our transport. So we did get a label. We got 24014 for our label. But notice we still only have one label, so we're running into the same problem as before. We're going to go to XRV number 9. And we will look at show BGP VPN v4 unicast labels. And here we have 24.0.14, so that's where we're getting our service label. Now we're going to take the same action we did before, where we cost out the link between XRV9 and XRV6. Now we're going to try a traceroute again and see how the traffic reroutes. So this time we are getting a second label, a transport label. So we have 16006 as our transport label. So again, we'll check Ceph. And here we see both labels getting imposed. 16006 for our next hop. And then for this next hop, we see the service label. Now 16006, and the outgoing label is the same. Now this tells us it's an SR prefix with index number 6. So index number 6 belongs to this router, and we will check that. In OSPF, we have prefix SID index number 6. Now the main difference here is the top label never actually changes, whereas in LDP, it's going to change, or should change, on every single hop. Here in SR, or segment routing, it does not change. It's the same label that's used throughout the network. And of course, the service label is always the same. And next, we're going to be looking at segment routing traffic engineering. We're going to be looking at one version of this. There are multiple ways to configure it. Our version of code is 6.5. So it used to be that we would use a tunnel interface similar to MPLS traffic engineering, but now we do everything with a policy. So it's very different. The RFCs have changed, and so we've changed it to in our code as well, so that we no longer use interfaces, we use policies instead. So in XRV 6, we are doing a couple things. We have an external community opaque called blue, and it's setting the value 3333. And we have a route policy. If our destination is in 3333/32, then set the external community blue. Everything else pass. And for our neighbor 9999, we are setting this route policy out, which means as CSR3 is advertising its own loopback to us, we then assign it an external community with a color, and that color then gets sent to XRV number 9. So let's look at XRV number 9. Okay, it's being a little slow there. So if we check under our RD for the prefix we want, we can see that our color is getting set under our external community. Now, if we want to do something with that, we need to actually set a policy. So we're going to do that. So here we have a segment list, and we're using our prefix SIDs in order to steer the traffic. So we're going to index 10, 11, 8, 7, 6. So we're going in the reverse path of the traffic engineering we did coming from CSR3. And then we have our policy with our color. So our color is defined. And then our endpoint is defined. Now, our endpoint, of course, has to be within our segment routing domain. Then we have to select a candidate path and the preference. So you can have multiple paths set up. And there are many, many ways to configure this. You can have dynamic, on-demand, explicit. So we have this one explicit path, segment list, the long way, using these particular MPLS labels. Then we can use show segment routing traffic engineering policy. Name. And we can see that it's admin up and operational up. And we have our binding SID 24013. And here's our binding SID within our MPLS forwarding table. It has no ID, but it does give the policy under the interface. So if we check show Ceph, we can see that our next hop is via 24013, which has a pop, and that's going towards our policy. And then we have our service label of 24014, and then our actual transport will be this set of segment IDs. So let's see how that looks. Now, you might have noticed something a little bit different about this, and this has to do with how segment routing works. Every single segment ID or every single hop gets pre-programmed, pre-labeled essentially. So we have 1, 2, 3, 1, 2, 3, 4. We have 5 labels here. Whereas in traditional LDP, even with traffic engineering, we would have 2 labels, sometimes maybe 3, maybe 4, but typically you're going to see 2 labels and they're going to get swapped at every hop. However, with segment routing, you defined at the head end what your labels are going to be throughout the entire network. So everything is predetermined. So we can see going from hop number 2 to hop number 3, this first label, 16011, disappears and 16008 becomes the next. So if we go to XRV10, which is our first hop, we do show MPLS forwarding. On 16011, there's a pop operation. 16008 keeps its label and keeps going. So that's how you can check for segment routing traffic engineering. Again, there are multiple ways to configure this. If you have any comments, or if you want to see a particular method of segment routing or segment routing traffic engineering, or MPLS LDP, or L3VPN, L2VPN, or even MPLS traffic engineering, please let me know in the comments, and I would be more than happy to accommodate that. Thank you very much.